about how calculations are performed in Java, including PEMDAS, the order of operations, and the quirks and potential problems with doing integer math. So what I need you to do is open up the demo code. We will be looking at various files in the Lab 2 demo code, and I will go through the slides describing what's going on with each file. In each program, when you have a variable and you want to assign a value to it, you have the name of the variable, an equal sign, and then the expression that you want it to be equal to. It could use other variables, it could use strictly numbers, and all sorts of math symbols, which we'll talk about. For the most part, they are the same as you would write in the typical math class. Plus is addition, minus subtraction. Shift 8, the asterisk, is multiplication. And division is the slash. It's the lower key where the question mark is. And modulus, which is modulo math, which is the percent key we'll talk about later on. So go ahead and open up int math and real math, and we'll run those and see the differences between integer math and real number math. First of all, integer math. Whenever you have an operation that involves two integers, the answer you always get is an integer, which is fine if you're adding. 6 plus 5 is 11. Right? 6 minus 5 is 1. 6 times 5 is 30. However, when you divide an integer by another integer, things get interesting. Because when you put two integers into a mathematical operation, you get an integer out. 6.5 should be 1.2, or 6 divided by 5 should be 1.2, but it comes out as 1 because it has to be an integer. There are some other examples down here in the notes. If you divide 2 by 3, it should be 0.66666, but you get 0 because an integer divided by an integer gives you only an integer. Likewise, 3 divided by 2 is 1, not 1.5. 2 integers in, 1 integer out. When you're using real numbers, that is to say doubles, ones that have a floating decimal point, you don't have that problem. You can add 6.1 and 5.2 and get the right answer. You can multiply, get the right answer. The only trouble you have is with precision. 6.1 divided by 5.2, if you run that file, you'll get the answer 0.899999999 when we know it's supposed to be 0.9. So the advantage of a double is that it can hold more data and has a decimal point, but it's not as accurate as we would like. Anything past like the 4th decimal point, we can't actually rely on when we're using doubles. And we'll see examples of that later on in the course, how that affects our programming. But just know that your precision with a double is going to be maybe 4 digits past the decimal point, not much more than that. So, division. 1 divided by 2, like I said before, is going to give you 0. When you divide by two integers, you get an integer out. 1.0 divided by 2.0 is 0.5. That's fine. You get 2 decimals in, you get a decimal answer out. How about when you blend them? We have an integer divided by a decimal number. What happens there? You can see that in the divide.java class. If you open up divide.java, it has some variations on that theme. For example, here you've got 1 divided by 2.0. Here we've got 2 divided by 3. Down here, 9.2 divided by 3. So when you run it, integer division is always rounds down. So 1 divided by 2 is 0. 2 divided by 3 is 0. However, if there's a decimal number anywhere in the division, you get a decimal out, keeping your accuracy. Likewise, if the decimal number is in the numerator, it's still a decimal, a double divided by an integer, so you get a decimal out. But again, the repeating 6's don't quite work. We won't trust our accuracy past about the 4th decimal point with double numbers. We do get a lot of digits and a decimal point, but it's not necessarily accurate as much as we'd like. So You really can't count on it past the fourth decimal. But if you do have a decimal number in your calculation, right, this division will give you a decimal number. Modulus, or modulo math, is division, but the only answer you get is the remainder. Let me show you what I mean. Right. 2 mod 3. What this will give you is the remainder when you divide 2 by 3. 2 divided by 3, it doesn't go in, but you have a remainder of 2, so it would give you the answer 2. 3 mod 2. Well, if you divide 3 by 2, it goes in one time with a remainder of 1, so the answer you get is the remainder equal to 1. If you look at the modulus class and you run it, two mod 3 is a remainder of 2. The division, because it goes in 0 times with a remainder of 2. 45 mod 10. Well, 10 goes in there. 10 goes in 4 times with a remainder of 5, so the answer you get is the 5. 9 mod 3. Well, 3 goes into 9 evenly, so there's no remainder, so you get 0. The mod operator, or modulo operator, also works with decimals. We won't be using that really, only rarely from time to time, but do definitely be aware of how it works with integers. If you have a remainder, when you divide the first number by the second, that's what you get. It doesn't have the other part, what the division result is. It only gives you the remainder. Which is, again, why 9 mod 3 comes out 0, because there's no remainder, it's not division. So, and it works with variables as well. If you have the variable num equal to 45, when you divide it by 10, well, it goes in 4 times with a remainder of 5, so you would get the 5 as the remainder. Also, again, the integer division, it goes in 4 with a remainder of 5. The integer division gives you the 4 part. You would get 4.5 on your calculator, but with integers, it's only the 4. And like I said, you could do this with real numbers, with floats and doubles, but we will use that very rarely, mostly due to the accuracy problems. But do be aware and cognizant and understand how it works with the integers. Java has order of operations, like any language that has math involved. And at the top, like in PEMDAS, things in parentheses. These ones here, the plus plus and minus minus, we'll see in just a moment. Here's your multiplication and division. Note that the mod operator is also on that same level as multiplication and division, because what it really does is divide and just give you the remainder. After multiplication and division, addition and subtraction. And these symbols here with the equal sign, we will also see in a moment that those and this level are known as mathematical shortcuts. We'll show you how those work next, as a matter of fact. So we'll go to assignment and shortcuts. Assignment. You can take any variable, any integer, give it a value, but the thing that makes it a variable is that you want to change the value. So later on in the program, say you want to add 5 to the value of num. That's great. Num plus 5 is 15. To store that, you would say num equals that expression. What Java does is evaluate this to 15 and then save that in the spot marked as num. So it went from 10 to 15. You can also do mathematical expressions, again keeping in mind order of operations. What would happen here? Well, it would do the multiplication first, 10 times 2 is 20, then add 7. So the value you would get for num is saved as 27. So whatever's on the right-hand side is always calculated first, whether it involves a variable or just numbers. Then that value is assigned, that is saved, under that variable's name. So do the math you want the calculator, or excuse me, the computer to do, is always on the right side. Where you want it saved is always on the left side. And we also have here the shortcuts I was talking about. Times equals. What that expression really is num equals num times 2. So it will take the value num, multiply by 2, and then save it. This is just a shorthand to save you some typing. Times equals 2 means take num, multiply it by 2, and then save it where the original value was. So you're changing the value by doubling it and then saving it. Likewise, divided by equal means take the value of num, divide it by 5, and that's what you will save num as. Keep in mind you also have integer. If num is an integer and 5 is an integer, you have the integer math. And it will be rounded down. You can change the value of the variable however you want. Just keep in mind your order of operations. The division will happen first. The addition and subtraction, it will do left to right. So after doing the division, it will then do the addition on the left and then the subtraction on the right. So PEMDAS applies, multiplication and division first. And if you have multiples expressions of addition and subtraction, it will do left to right. Likewise, parentheses come out on top, so we'll do the 4 plus 5 first. Then the division. So 9 divided by 2 is 4 because it's integer division. Then adding 7, we get a total of 11 for the answer. The other shortcuts you will see, plus plus. What that does is add 1 to your value. So num goes from 11 to 12. And I should warn you, you'll see this all the time. So you should be fluent with this phrase. Num plus plus means just add 1 to the value of num. Likewise, minus minus, you guessed it, means subtract 1. So it goes from 12 to 11. So plus plus is a shorthand for add 1. Minus minus, a shorthand for subtract 1. And you will see those two all the time in Java programs, so make sure you're able to use them and understand what it means. Again, multiplying by 5, right? Take num, multiply it by 5, save it as the new value. This will then take that value you just saved, which is 60, and multiply it by 2. So now you've got 120. Divide it by 10. That value you just had, 120, gets divided by 10. You now have a value of 12. You can do the same thing with the modulo operator. What's the remainder when you divide 12 by 10? Well, that remainder will be 2. And you will get an output that num will have the value of 2 now. Also, there are some specialized math functions inside a math class in Java. There's a separate file called math, which saves some very high-level math functions. The only one I'm going to show you right now is the math.pow function. What that does is take whatever number you have here and raise it to the second number's power. So the value of num is 2. So it's going to take 2 to the third power. That's where the 8 comes from. So this is the base, this is the exponent, and it will output whatever you get from that. And I have a link on the Moodle site leading to the site that will explain all the functions in the math class. Right now I just wanted to introduce you to the first one. You can raise whatever number you want to whatever power you want. These can be integers or doubles. It will work either way. Casting. This is a way of turning a number into another type of number for the short term. Suppose, for example, I have my favorite number, 3.14159, but suppose for my next calculation I only want the integer part. I put the word int in parentheses in front of it, and it casts it as an integer just for that calculation. So that calculation would just use the number 3. Likewise, I can have Java pretend that this integer is actually a double, so it will do a calculation as though it were 3.0. This is one way around the integer math problems we saw earlier when we're dividing by integers. If you cast a number, one of the numbers, as a double, it's no longer integer divided by integer. You don't have the decimal problem. So if you go to the cast class, we have some values we've declared as various. We have an integer and a float, a double, another integer. What you can't do, you cannot make 1 equal to 7.56. Right? 1 is an integer, this is a decimal. Likewise, you can't make the integer 2 equal to this float. Even though it's 453, the computer thinks it's 453.0. This assignment will not take place. You'll get a compiler error. The program won't run. However, using the casting, you can have the computer pretend that this is an integer just for this calculation. It will save, what it will save in spot 1 is the integer version of this value. So 1 will get the value 7. Likewise, this float up here, if it took the integer version of that, it would take 453 instead of 453.0 and would save the value 453 in it. Note, these would definitely be integers now. Even though they started off as floats and doubles, this is saved as an integer as 7. This is saved as an integer, 453. But you can convert these to integers for the short term. If you use them later, they'll go back to being doubles and floats. It's just this one line where Java treats it as an integer. And again, one of the more useful things about casting is you can make Java pretend this number is a double. So you'll get a decimal answer out of this division, and you will avoid the problems of rounding off. Integer divided by integer, you would get the answer 2. But if you make one of them a decimal number, you get the correct answer in decimal form of 2.2. And here's in cast, you have some more examples of that kind of math. We have integers pretending to be doubles, and therefore you get the right answer, versus when they are treated as integers, where you get the integer answer. Compile it and run it. You'll see what that means. 1 divided by 2 is 0, because they're both integers. If you cast the first number as a double, it gets treated for the purpose of calculation as a decimal. You get the decimal answer 0.5. Likewise, it works in the denominator, dividing by what is really 2.0, you get the correct decimal answer, 2.5. So the casting is good for the short term to avoid potential mathematical problems. What we will do in class tomorrow is work on the worksheet. If you have not finished the labs from yesterday's class, you should continue on those. Bring any questions you have, including questions about what you've seen here. Thank you, and have an excellent evening. I'll see you in class next time.